It's Dr. Eric Ballcabbage, and we're back for this week's Thursday thyroid video. So, I'm going to rehash what I talked about in the previous two videos, a little bit of the basic physiology. We also talked about the difference between a standard thyroid panel and a comprehensive panel, and why there's an importance difference in running a more complete panel. So, we said that every cell in the body has a thyroid receptor on it. And it is when free T3 binds to that receptor and it's pulled into the cell that thyroid hormone then helps establish and run our metabolism. We talked about thyroid hormone being like the accelerator pedal. The more thyroid hormone you get into the cell, the faster our metabolism runs. And so when the cell becomes low on thyroid hormone, signals go to the hypothalamus. Hypothalamus then sends signals to the pituitary gland, which is another gland in the brain, and to really via the hormone, thyroid releasing hormone. Pituitary gland gets the signals, hey, we need more thyroid hormone. It produces thyroid stimulating hormone, which then goes off to the thyroid gland, which is that gland right in the throat, in the neck area, that to then produce and release thyroid hormone. Two thyroid hormones produced, T4 and T3. We said T4 is the active form, T3 is the active form, T4 is the inactive form. T3 is ready to go, so it gets released from the thyroid gland, binds onto something called thyroid binding globulin, which is the taxicab, which carries thyroid hormone around the body. As it carries it around the body and finds a cell that needs some thyroid hormone, it releases the T3. That T3 then becomes free T3, which can then bind to the receptor and be pulled into the cell. Metabolism works. The T4 that's made by the thyroid also binds to a thyroid binding globulin. That's the vast majority of the thyroid hormone that's made by the thyroid gland is T4, 93% inactive hormone, and it needs to go to other tissues in the body to be converted into T3. So it'll go off to the liver. About 60% of the T4 is converted in the liver to T3. About 20% is converted via the gut to T3, and about 20% is converted in the peripheral tissues to T3. Once we have T3, it's bound to thyroid binding globulin, the carrier molecule, which escorts it around the body. Once it finds a cell that needs thyroid hormone, it releases the T3. That T3 becomes free T3, docks to the receptor on the cell, gets into the cell, metabolism works. As that works better, the signals decrease. As the signals decrease, we make less. When the cells need more, it kicks this back into gear. So this is a constant cycle that's going on and on. We talked about last time that a standard traditional thyroid panel, whether it's run by your primary, run by an endocrinologist, is typically a TSH and a T4, or a TSH and a free T4. And we said that was only good for measuring the top part of this thyroid physiology. It doesn't help us with the whole part of the physiology. If we just look at this, TSH and T4, we may have TSH, we may have T4, but if we're not converting T4 into T3, it really doesn't matter what these values are. T3 is what actually gets into the cell, so it doesn't matter necessarily what your T4 is. You could have normal T4 values and still have inadequate free T3 getting to the cell and getting into the cell. So I talked last time that this is really an inadequate way, and really an old-fashioned way of looking at thyroid hormone physiology. This is a more comprehensive panel, and this is what should be done on people when we're taking a look at their thyroid physiology. We need to look at a TSH, we need to look at T4, we need to look at T3, free T4, free T3, reverse T3, T3 uptake, thyroid binding globulin, TPO, TGA, and TSI antibodies. And these are all these antibodies are associated with autoimmune attack against the thyroid gland. We'll talk about that in future videos. So that is a more comprehensive panel. And I'll go one step further. I think that if you're going to get a thyroid panel done because you have health problems, you should have a comprehensive metabolic panel done as well. You want to know what your glucose is. You want to know what your hemoglobin A1C, what's your cholesterol status, triglyceride status, what's your iron levels, what are your RBC indices. You really want to know what's going on with the whole system. So a comprehensive metabolic panel should be done along with a comprehensive thyroid panel. Now, just like comprehensive panels used to be big and now traditionally this is what a thyroid panel looks like, Metabolic panels used to be 50, 60 tests. Now a traditional metabolic panel is maybe 10 or 12 tests. So the tests have really shrunk down for various reasons, most likely because people don't want to pay for them, especially the insurance companies. But really a comprehensive test gives us a fuller understanding of what's going on with somebody's physiology. So I said last time, we also need to take a look at not just what tests we run, but also we want to take a look at what's the range that we're using when we're taking a look at thyroid physiology. The range is used on a traditional lab work, and the range is used in a functional medicine practice can make all the difference in helping you understand whether you have a thyroid condition or you don't have a thyroid condition. So let's talk about functional ranges or optimal ranges versus lab ranges. So I'm going to erase a little bit of this. And we're going to talk about lab ranges, kind of like grades in school. So, lab ranges are based on a bell curve. And what essentially happens is everybody who's going to the lab to get blood work done, the labs then create a range. And so just like we have grades in school, we have lab ranges. And lab ranges that your doctor uses, your medical doctor, your endocrinologist uses, are not based on the optimal range the body runs in. They're based on really a sick range or a disease range. So what happens is there's an optimal range that the body runs in. And this, let's say this is the A grade in school. 3 standard deviations away from that is where your doctor looks at, this is the lab range. And so we'll call this the B, the C, the D, and the F. B, C, D, and F. And so if your child had a math class and had a math test, most likely you would want them to get an A on their math score. If they came home with something closer to a C or D, you would probably, I would hope, still be concerned. They didn't get an F, they didn't fail, but they didn't get an A either. If it's my child, I'm thinking, what didn't they understand? And that's kind of how we want to look at blood work. If your blood work, your range in blood work is here, in a D- range, it'll still be within the lab range. You could still be symptomatic because you're not within the optimal range the body works in. So you're still symptomatic, but by lab ranges and insurance ranges and insurance standard, you're not sick enough to treat. As soon as your range goes outside of that 3rd standard deviation away from the norm, now you're in the failure range. Now there's medical necessity to treat you, and your doctor will probably prescribe some Synthroid or some type of hormone support. But if you're in the optimal range, you're probably not going to have symptoms. But if you're in this B, C, D range, you are probably still going to be symptomatic. You'll still have symptoms, but your doctor's going to tell you don't have a thyroid problem yet because you're not quite outside that range. You could be 1/10 of a point away, 1/100th of a point away. As long as you're within the range, there's probably not medical necessity to treat. In a functional medicine model, I want you as close to the optimal range as possible. Matter of fact, I want you in that optimal range. And if you're not in that optimal range, then we need to help you get in that optimal range. We have to figure out why you're not there. Because as soon as you leave optimal range, you could start being symptomatic. Okay? So this is why when you go to your primary care physician, you could have all the symptoms in the world, but you're not sick enough yet to be outside their broad lab range for them to be able to treat you and say, yes, you have a disorder disease. So let's talk about how this range is established. There's one other point here. If this is the optimal range the body works in, then we go 3 standard deviations out, and that's done so that 95% of the people that get lab work done can be considered normal. Only the sickest 3 to 5% are outside of that lab range. So what establishes that lab range? Well, it's based on everybody who's getting lab work done. And so because it's based on everybody getting lab work done, it can skew the value, because the people that are typically getting blood work and lab work run, especially thyroid hormone panels, is not healthy people. They're sick people, people who don't feel well. And so if the broad part of your base is people who are sick and don't feel well or are on medications, that can skew our values. So instead of having a smaller range, if we just used a whole bunch of healthy people, our range would be much tighter. If we're using a lot of sick people, our range gets wider so that we can keep 95% of the people within that lab range. So we want you to be aware that when you look at your lab panels and your doctor tells you you're normal, what we really want you to use are what are called the functional ranges, and that's what I'll use as a physician to determine whether you have a thyroid problem or not. If you're not in the A range, your body and your physiology and your thyroid needs help. We then need to establish where that thyroid physiology is breaking down. Not just that you're not making T4, but which step of this thyroid physiology is breaking down. We want to look at all of these markers. All of these markers help us clue into where the thyroid physiology is breaking down. So that's this Thursday's Thyroid Thursday video. In here we did a review of the basic thyroid physiology. We reviewed the standard thyroid panel versus the comprehensive panel, and we reviewed the difference between a functional range or optimal range that the body works in, the subclinical or symptomatic range, which I call the B, the C, or the D range, that your doctor would still consider you to be normal or healthy. And then we talked about where the lab range is, which is 3 standard deviations out. So you've got to be sicker than 95% of the people to be outside and be in that failure range. But if you wait till you get an F to start taking care of your physiology and take care of your thyroid function, that's like telling your child, we're not going to help you with any of the math or get you a tutor until you've started to fail the class. And you don't want to do that. The first time you see your child gets a B or a C, you probably want to be taking a look at them, their study habits, taking a look at their homework, and start to say, okay, what don't you understand here? Because if you don't fix it when it's a C, you'll probably have a D on the next test. If your labs are in this BCD range, they're out of the optimal range, if we don't do anything to fix the physiology, sure enough, given a long enough period of time, eventually your thyroid is going to be so dysfunctional that you'll get to the F range. But I find that the vast majority of my patients never get outside that functional range or outside that lab range. And so a lot of their doctors say that there's nothing wrong with you, you're just crazy, nuts, lazy, or you eat too much or something along those lines, versus, wow, if you're tired, fatigued, your hair's falling out, even though your TSH and T4 levels look normal, there's got to be something wrong with your thyroid physiology. So that's this Thursday's Thyroid Thursday video. I'll talk to you next week. We'll have some more information for you. All right? Thank you.